Friends, welcome to my channel. So today I have come up with a question from particle physics. The question is about whether a particular particle physics reaction is possible or not. I think many people have been inquiring about this question in different groups, so that is why I chose this question for today. So the question is, which of the following elementary particle reactions or decays are allowed under various conservation laws? If allowed, write down the type of interaction and the characteristic time by which it would proceed. So it is already written that a reaction, if it is possible, it has to obey certain conservation laws. So depending on the type of the particle, the type of the reaction, these laws may vary. So I have taken a summary of the conservation laws to be followed in different reaction. So we know that the main interactions in particle physics are strong interaction, electromagnetic interaction and weak interaction. Strong interaction is strongest, electromagnetic is the second strongest and weak is the weakest interaction. So the different in this we can see that different conservation laws for this kind of interactions. So we can see here that charge, lepton number, baryon number. These three are conserved in all interactions. The thing that different is isospin, the exact component of isospin and strangeness. So let us first of all look into the question and see which of the reactions are possible or not. So the first question is that of P plus N gives lambda 0 plus sigma plus. P is proton, N is neutron, lambda and sigma are some other particles. So we have to see the conservation laws. So first of all I will write here C, L, B, I, Z and S. I will explain. C is a charge, L is a lepton number, B is a baryon number, I is isospin, Z is a Z component of isospin and S is the strangeness. So charge of proton is plus 1, neutron is 0, this is 0, this is plus 1. So LHS we have total charge is plus 1, RHS we have total charge plus 1, so charge is conserved. Now let us take lepton number. Lepton number for a baryon it is 0, therefore lepton number is also conserved. Now let us take baryon number. For all baryons, baryon number is 1. So this is 1, this is 1, this is again 1, these two are 1, therefore it is conserved. Now let us take isospin. So the question is how you will calculate isospin. So suppose the number of particles, the number of members in a particular multiplet I think or I don't know. Suppose proton and neutron are taken, they are a multiplet. So number of members in proton and neutron multiplet is actually is 2. So if the number of members of the multiplet is n, then n is equal to 2i plus 1, where I is the isospin. Similarly, if charge of a particle is q, q is equal to Iz plus b plus s by 2, where b is the baryon number, s is the strangeness. So let us calculate this. First of all we will write I. So here proton and neutron are in the same multiplet. So the total number of members is 2. Therefore 2 equal to 2. 2i plus 1. From this I will be getting as 1 by 2. And for this also this is 1 by 2. Now let us see for lambda 0. Lambda 0 the multiplet total number of members in the multiplet is 1. So this is 0. For sigma plus we know sigma plus is here, sigma minus is there, sigma 0 is there. So total number of members is 3. So therefore the I value will be equal to 1. So total isospin and the left hand side is half plus half is 1, right hand side is 1, therefore this is also conserved. Now let us say the strangeness. Strangeness of proton is 0, strangeness of neutron is 0. Sigma 0 has a strangeness minus 1, lambda 0 has a strangeness minus 1, sigma plus has a strangeness minus 1. So this is not conserved. Now we cannot say which type of reaction or it is not possible without checking IZ also. So the equation for IZ is already given here. That is Q is equal to IZ plus B plus S by 2. So we just add B plus S, then divide by 2. Now the charge is plus 1. So now we will get IZ here as 1 by 2. Here it is minus 1 by 2. Here it is 0, it is 1. Again it is not conserved. So there are like IZ is not conserved and strangeness is not conserved. This reaction is not allowed as per conservation laws. So this is how we have to solve this. So I will explain it once more in this next reaction. Let us take the next reaction. The second reaction is pi plus n gives lambda 0 plus k plus. Now what will happen? Again we will write C, L, B, I, Z and S. Charge here is plus 1, this is 0, this is 0, this is plus 1. So charge is conserved. Lepton number is 0, 0, 0, 0 because these are baryons, therefore it is conserved. Baryon number is, this is a meson, therefore baryon number is 0 and again this is baryon, therefore it's plus 1 and here it is plus 1. K is a meson, therefore it is 0. So LHS we have plus 1, RHS we have plus 1, this is conserved. Now let us take I. So how will we calculate I? N minus 1 by 2 equal to I, where n is the number of members in the multiplier. So we know that pi plus, pi belong to, there are like pi plus, pi minus and pi 0. Therefore n is equal to 3. Therefore I is equal to 3 minus 1 by 2 equal to what? I think everyone got it. So this is 1 and for n is like, there is n and p only. Therefore number of members in the multiplier is 2. Therefore I is equal to 2 minus 1 by 2 equal to 1 by 2. So therefore this is 1 by 2. Lambda 0, it is 0 because there is no other particle. For k plus, there are like k plus and k0. So therefore again it is just like we have calculated in the case of neutron. This is also half. This is not conserved. Now let us see the strangeness. We know that strangeness of pi plus is 0, neutron is 0, lambda 0 is minus 1 and k plus, even though it is a meson, it has a strangeness which is plus 1. Therefore the total become, and the LHS it is 0, RHS is minus 1 and plus 1, therefore it is 0. Therefore this is conserved. Now let us say IZ. So we have already know expression for IZ because its Q is equal to IZ plus B plus S by 2 or IZ equal to Q minus B plus S by 2. Now how will you calculate Q? Q is a charge. So let us take pi plus. What is the charge of pi plus? Is plus 1. Plus 1 minus B plus S is 0. Therefore the IZ value of this is plus 1. Now for n, what will happen? The charge of n is 0. B plus S is 1. So this become minus 1 by 2. For lambda 0, this is 0 and for k plus, the charge is 0. Sorry, charge is plus 1. Therefore this become B plus S is plus 1. So we will get it as plus 1. Okay, so this is again, you add here, sorry, plus 1 by 2. Because this B plus S is plus 1, charge is plus 1. So for 1 minus 1 by 2 is plus 1 by 2. So when you add here in the LHS, we get 1 minus 1 by 2 equal to 1 by 2. And 0 plus 1 by 2 is also 1 by 2. So LHS we have 1 by 2 total, RHS we have total 1 by 2, therefore this is conserved. Now you see this interaction, we can see that only the isospin quantum number is not conserved, all other quantities are conserved. And let us look at the table. So it is written here in this table, here You see here, electromagnetic interaction. IZ is conserved, strangeness is not conserved, but IZ and strangeness are conserved, but isospin is not conserved. So we can say that this reaction is possible and this is a electromagnetic interaction. Electromagnetic interaction. So this is how you will calculate the rest of the particles also. If you have any doubt, you can comment on the comment section. I will give you the answer. But otherwise this is going to be a lengthy video. So I don't want to make every video lengthy. So this is how we can check whether a particular interaction is possible or not. So I hope everyone understood this. So this is the logic. This is the logic. The table you have to memorize. You have to have a clear idea of which interactions, which quantum number is violated, which is conserved. If you know that, you can easily calculate, easily check whether a particular interaction is possible or not. Okay, so today this is with this I stop for today because I don't want to make this lengthy. So we will meet in the next video with a new question. Till then, goodbye.